Hello, welcome to Mathy Python. In this video, I look at solutions to the problems for error handling. In problem one, without running it, first identify the exception type each line raises and explain why. Then run each one to verify. So our first line here is trying to convert a string to an integer. You cannot do that. 1 divided by 0 is a divide by 0 error. It's asking what number times 0 gives you 1. There is no such thing. The third one, it's saying hello, look at index 10. Hello does not have 10 characters in it. So that's going to be an index out of range, an index error. Let's see, I define a dictionary as a key of A with value 1 and then ask what is the value associated with B. And there is no value associated with B. So that's a key error. Let's see the next one. You cannot convert a string of float to int. So you can't. 1.5 within quotes makes it a string, and int will not figure out how to convert it from a string to a float and then a float to an int. Too many steps. You could, however, do an integer cast of a string with an integer in it, like here. And you can do an integer cast of a float. You just can't combine those. Problem 2, wrap each line from problem 1 in a try except block that catches the specific exception and prints a descriptive message. So try except value error. So int hello, as we saw, will have a value error, so it'll print not a value. The second one, we catch the zero division error. Then for the next one, the index error, then the key error, then the value error. So the point here is that if you use a try except block, then your program will not crash. You can deal with the error. Problem 3, write a function safe divide AB that returns A divided by B, but catches the zero division error and returns none instead of crashing. Test it on a couple of test cases. So we define safe divide. We try to return A divided by B. If we get a zero division error, then it returns none. So line 8 will be okay. Line 9 will throw that error. Problem 4, what is the difference between these two except clauses? Which one is preferable and why? So the top one is a general exception, very broad. The second one catches very specific errors. Problem 5, write a function safe int of s that tries to convert a string to an integer and returns none if it fails. Test it on various cases. So safe int of s, wrap the casting of the string in a try except block. If you get a value error, return none. So 42 is okay. 3.14 is not, because it's float inside of a string. Line 10 doesn't work at all because hello doesn't make any sense as an integer. And then casting a string that contains an integer to an integer is fine. Problem 6, write a function validate triangle ABC that raises a value error with a descriptive message of sides don't form a valid triangle and returns true otherwise. So to be valid, the sum of any two sides must be greater than the other side. So A plus B is greater than C, A plus C is greater than B, and B plus C is greater than A. If all of that is satisfied, then it returns true, else we raise a value error. Run the function first. So 3, 4, 5 is fine, 5, 5, 8 is fine. 1, 2, 3 is not. 1, 2, 5 also not. Problem 7, Write a function, safe list access, pass it a list and an index that returns the element at the given index or a descriptive error message if the index is out of range. Test it on a list of 5 elements with valid and invalid indices. So I try to return the index of the list. If there's an index error, then print that out. That's an invalid index for that list. Try it on my list and then access various elements. Invalid index 10 for this list. Also invalid index 100. 8, write a function load scores file name to read scores.csv and returns a list of name score tuples. Use finally to print file operation complete, regardless of whether the read succeed or failed. So here we have a try except finally. So in the try, we attempt to open the file, split the lines, make tuples out of them, append them to the scores list. If the file is not found, then we print that out. Regardless of what happens, we print the file operation is complete. The point of it finally is that it attaches this line of code. It attaches its block of code to the try except. You could just put a line below the try except, it'll run. So why finally? Because finally tells the programmer that this belongs to this try except block. So then we try this on various data files. So we try it with scores CSV in the root directory, which doesn't exist, data scores CSV, and then some others. So we see file not found. It is in data. Or CSV right there. Yeah, and it returns tuple, or it returns a list of tuples. And the other data files were not found. Problem 9 says write a program that repeatedly asks the user for 2 numbers and divides them. Catching zero division error and value error separately, the program should keep running until the user types Q for either number. So I write while true. That means I have to break out of the loop somewhere to avoid an infinite loop. Then we try. If we get a zero division error, we'll print cannot divide by 0. If we get a value error, we'll say it's not a number. And then it'll go to the next iteration of the while loop. So notice that it doesn't stop the program on either of these errors. It will keep going until the user types Q. So X is the input if it's Q break. Y is the second number if it's Q break. Cast X to an integer. Cast Y to an integer. If that can't happen, then you get a value error and it goes to the next part of the loop. Then you do the division. If you get a zero division, it says you can't divide by 0 and you go through to the next iteration of the loop. So let's say 1, 2, that's fine. 3, 4, 5, 0. Cannot divide by 0, but then it goes back through the loop, so we can try again. If we didn't have try except here, the program just would have crashed. But here we've recovered gracefully. We'll say 2 divided by the word 4. That's not a number. Okay, and now let's quit. Problem 10 is a robust CSV reader. Write a function read scores safe file name that reads scores CSV and returns a list of valid rows. Skipping in a row where the score cannot be converted to an integer. Log each skipped row to a separate file. Errors.txt with a message explaining why it was skipped. So we're making a log file of errors, which is standard practice and a very good one. So we write a function here, read scores, file name, the log file. Try to open up the file name. Make the log file as a write, so this will overwrite whatever log file is already there. You want to keep a running log, then make that an A. Valid is an empty list. We skip over the header. Let's see, we iterate over the file name, keep track of the index and the lines, split out the data into name and score, try to cast the score into an integer. If we get a value error, then we get a message. Then we pull out the grade and we append valid. File in, we give it a file, errors, we give it a file, then we read scores. So let's take a look at scores with errors. So you see score for this person, Fern, that is not a number, that won't make sense. And then these were left blank. Those will also give errors. And then the log file, row 5 is invalid, score 5 or 4 cannot be converted to an int. 6 is also valid because there's a missing score. Number 11 is a defensive calculator. Write a function calculate expression that takes a string like a 10 divided by 2 or 5 plus 3 and evaluates it safely. Handle division by error. Handle division by 0, invalid operators, non-numeric operands, and malformed expressions, each with a specific error message. Support plus, minus, multiply, and divide. Do not use eval. So we create a function here called calculate. We have our operators, our set of operators, plus, minus, multiply, divide. To parse the expression, we take the expression, strip the blank space from either side, and then split it. If the length of the parts is not equal to 3, it's malformed. Yeah, so it has to be some number, then an operation, then some number. So if you don't have 3 of those, it's malformed. We'll say left operator and the right are equal to the parts. That's where we split it. So left will be the first number. Operator will be the thing in the middle, which is an operator. Right will be the right number. So validate the operator. If the operator is not in the operators, then raise a value error. Cast the left into the float of left. And if that cannot happen, it's an invalid left operand, similar for the right. If it's passed all those tests, then perform the calculation. If the operator is plus, add them. If it's negative, subtract them. If it's multiply, multiply. If it's divide, divide. And then if the right is a 0, then raise a 0 division error because you can't divide by 0. Otherwise, return left divided by right. Look at all these test cases, loop through them, print it out. 10 divided by 2 is 5. 10 divided by 0 is can't divide by 0. 5 plus ABC, invalid right. 5 $, that's an invalid operator. 5 plus 3 plus 2. We were expecting 2 numbers with an operation in between. 5 does not have an operation, and of course blank does not work at all. I hope you enjoyed these and found them challenging. If you leave a comment in the comments section, yeah, happy programming.